talking to David one day, he said, you know, we really should look at the aerospace industry to see what practices they made and apply that to this rollout of autonomy. And I thought, I heard someone speak from the aerospace industry, and that was in San Francisco, and I had heard Christopher Hart speak on that topic. And he is a gentleman with 30 years of experience heading up the FAA. Plus he has experience in the NTSA as well. So next, I'd like to welcome Mr. Christopher Hart.
Good morning, everyone. Thank you, Marta, for that very kind introduction. What a great honor and privilege it is to be asked to be a keynote speaker at the first World Safety Summit, the first Velodyne World Safety Summit. So thank you very much for that opportunity. So Marta asked me to be brief, but I'm an attorney. An attorney's number one credo is never use one word when two will suffice, but I will try nonetheless. So are driverless cars doable? Absolutely. I am such a gadget geek, and I am so excited to be playing a role. Is this the one that I gave you? This doesn't look like the one that I gave you. I may just have to speak from. This is not the revised one, I don't think. Not to worry. It is absolutely doable, and I am so excited to have this opportunity to see us move from decades of mitigating the effects of an accident with belts and bags to preventing the accident in the first place. What an amazing ounce of prevention, pound of cure. I mean, what an amazing opportunity this is to play a huge role. And so I come from the standpoint of the NTSB. Marta mentioned I was chairman of the NTSB, so we are the federal agency that looks at transportation accidents and figures out what went wrong and figures out how to recommend keeping it from happening again. So that's what she's asked me to do, is to see what we can bring to the table to help, as we say, introduce this new technology with the minimum of missteps. So the automation in aviation has had so many benefits. It's had huge safety benefits. That's obvious. Look how many years they went from 2009 until just a few months ago without killing a single passenger on a U.S. airline. Look what an amazing feat that is. Won't it be nice when we can say that for the car world? Not to mention operating efficiency for the airplane. Wow, what an amazing efficiency improvement, productivity improvement device automation has been. System throughput, allowing more airplanes to transit the same airspace because of automation. The amazing pollution benefits from, the environmental benefits from automation. And I'm convinced that automating cars is going to produce those benefits and many, many more, many that we can't even foresee today. So to me, that's going to be a huge, huge transformation in the way the world does business. It's an amazing comparison to aviation, because when the Wright brothers first flew in 1903, they got maybe a few newspapers on page B6, Wright brothers flew. They couldn't get any interest in the US. That's why they went to France, because nobody was interested. It was amazing to look at that comparison, that after the urban challenge, DARPA Urban Challenge in 2007, we're now 11 years from that, and for the first several years, people went to the major auto manufacturers and said, wow, look what we just did with the DARPA challenge. And they got a big yawn. Really? So what an amazing comparison that is with the same story that aviation saw many years ago. So the issue is really not, can we automate? The issue is, how can we do it with the minimum of missteps? Because admittedly, the public is very, very skeptical about this idea of automating cars. How many people today would not get in a driverless car? That's the skepticism we're facing. And if we have unfortunate events because of not learning from the past, that's going to make this skeptical public even more skeptical. So the question is not, will it happen? The question is, can it happen while minimizing the missteps? So I'm not sanguine about the predictions that 2 or 3 years we're going to see streets full of driverless cars, but it's coming, and it's definitely coming, and it's just a question not of whether, but of when. So how do we minimize missteps? Aviation's been automating for decades, and they still have automation crashes, and they still have pilots. So the joke about the airplane of the future is, you get in the airplane of the future, you're going to see a dog and a pilot. And the pilot's job is to feed the dog. The dog's job is to bite the pilot if he touches anything. So that's the airplane of the future. So just bring this down to the real world. If the airplane that Sully was flying and landed in the Hudson River had been automated, what would the automation have done? That's why there's still pilots in airplanes. Well, of course, The results of that in airplanes can be far more serious than the results in cars, but the point is we need to get better and better, and we need to bring this into public use while minimizing the mishaps. So I would submit that the AV industry can learn loads and loads of lessons from aviation lessons learned rather than repeating those same mistakes over again and doing what aviation learned from and not learning from it and doing those over again. So let's look at, I'm going to start with a very high level of what can be learned from aviation. The first high level is the importance of collaboration. Collaboration is the main reason that aviation is as safe as it is. So here's what happened. From the 50s to the 90s, the accident rate was coming down wonderfully until in the early 90s, it was kind of getting stuck on a plateau. And so people were getting very concerned. And the reason it was getting stuck on a plateau was because it was doing what most safety curves do when you implement new technologies. And it's new technologies that resulted in this huge downfall of the accident rate. So the new technologies were like jet engines, which were much more reliable than piston engines. Automation itself had huge safety benefits. So simulators. So now you can practice things in a simulator with a pilot that you never want to do in a real airplane because it's far too dangerous in a real airplane, but if the pilot ever sees it in a real airplane, okay, been there, done that, I did it in the simulator. So there's all kinds of ways that you can improve safety by, that the safety was improved by those technological improvements, but as with most technological improvements, they were asymptotically approaching their limit and reaching a plateau. So in the early 90s, as that accident rate reached a plateau, meanwhile the FAA, the Federal Aviation Administration, is projecting double the volume of flying in the next 10 or 15 years, so simple arithmetic tells you flat rate times double volume means that Joe Public is going to see twice as many smoking burning airplanes on CNN, and that frankly scared them. And so they said, we got to do something different, because if we keep doing what we've been doing, we're going to keep getting what we've been getting, which is this plateau. We got to do something different, and the something different they did was collaboration. So they brought everybody to the table. They brought the airlines, they brought the manufacturers, they brought the pilots, they brought the controllers, they brought the regulator even to the table. Everybody was around the table collaboratively looking at what are the problems, prioritizing those problems because they realize quickly they're going to see more problems than they have resources to address. So what's going to be front burner, what's going to be back burner, then implementing solutions for the prioritized front burner problems, and then evaluating, A, is the solution working, and B, is it having unintended consequences? Because that's always a challenge in complex systems of subsystems that are coupled together, working together, that all of the pieces of all the subsystems have to work together successfully for the total system to work. And when you make a change in one subsystem to get a change that you want, what kind of unanticipated, unintended consequences are you going to get from this complex subsystem? So that's been a huge, huge challenge, and that collaboration is a large part of the reason why aviation has been as successful as it has been. And I would say, even though one size doesn't necessarily fit all, the collaboration that Marta mentioned, I see huge opportunities for collaboration in this industry to help make it better. Now, the collaboration is for the purpose of determining what the objectives are going to be. That's what the collaboration is all about. Once you get to the collaboration, and by the way, there is precedent for this in this industry, because the example that I'm thinking of is autonomous emergency braking. Look at how the auto manufacturers collaborated. What an amazing success story that was, to have them collaborate to agree on autonomous emergency braking systems rather than wait for 10 years for a regulation. So under leadership of Mark Rosekind at NHTSA, the manufacturers came together and collaborated on an agreement regarding AEB. So they can do it, that's clear. But once you collaborate, then that's where vigorous competition steps in, because you got the objectives from the collaboration. The competition is for determining how to meet those objectives. That's where you need vigorous competition, because the competition forces ever improving products. And that's why everybody who's in this room, you're all in a vigorously competitive market, and that's a good thing because that forces continuing improvement of the technologies. So what an amazing success that has been. I would submit that this collaboration has huge opportunities for the AV industry as well, for setting the objectives, but then going to the vigorous competition phase. So so that's very high level. Collaboration is provides a huge opportunity to take a complex system, which this certainly is, and make it work better. And the reason, by the way, one of the huge benefits of this collaboration is not only that it improved safety, but while it was improving safety, it improved productivity. What an amazing development that was, because usually you think when you improve safety, you hurt productivity. Improve productivity, you hurt safety, but this improved both of them at the same time. Why is that? My theory, because everybody's at the table. And so when they're talking safety, they're thinking productivity. So if something hurts their productivity, it's never going to see the light of day in this collaborative process. But if they're, so that's one of the reasons why it improved safety and productivity and just flew in the face of conventional wisdom. Here's another thing it did. It minimized unintended consequences. What a huge challenge in complex systems. Whenever you make changes, and the reason, again, my theory, because everybody at the table is talking safety, but they're thinking everybody to whom these unintended consequences might occur is at the table. That's why these unintended consequences don't occur, because everybody was involved. And the moral of the story is really very simple. If you're involved in the problem, you need to be involved in developing the solution. That's what collaboration is all about. And that's what aviation showed, and I would submit that that's a huge model that this industry can follow, because it was such a powerful success story in aviation. It can be a powerful success story here as well. Then once you collaborate and agree on the objectives, then that's where the vigorous competition comes in to fuel the continuous improvement and betterment of the products. So that's at a very high level. Now let's come to the automation level and look at some of the automation lessons that can be learned from aviation. Number one, the importance of automation being human-centric. So if I go to a techno geek and the techno geek says, what's this human of which you speak, we've got a problem, because the human is going to be in the system. So just to give you an example, if your car is so good that it doesn't require human attention, you've already heard reference to this morning, then guess what the human's going to do? Not give any attention. The human's going to become complacent and disengage from the task. So if your system is so good that it really doesn't need the human to be there most of the time, but like Marta said, okay, we're almost ready. Well, you ain't quite ready until you're really ready. So most of the time, the human doesn't need to be there, so guess what's going to happen? Most of the time, the human is going to be disengaged. That's just human nature. So if you're designing systems that are so good that it doesn't need any human attention, then that's what you're going to get. You're going to get disengagement, complacency, lack of attention from the human. That means you are not thinking human-centric in your automation. Here's another one. It's important to have graceful exits if things go wrong. So one of the things that could go wrong, that's pretty unlikely, I have to admit, is failure of the system. In aviation, I can't tell you a commercial airline crash that resulted from failure of the automation. And I would think that there's probably two reasons for that, because we would only get there if there was actually a crash or a near miss. Two reasons why the NTSB weren't there. One, because the automation is very reliable, but not totally, because there's always a possibility of failure. But number two is, if it doesn't work, it's very robust at telling the pilot, I am not in the picture anymore, you need to take over. So between those two things, I think that's why I can't give you an example today. I can give you some automation examples, but they won't be in aviation. So number one is you need to have a graceful exit. What if the automation fails? And if you're still thinking the automation can't fail, then you need to look back 100 years when they said, this ship can't sink. Well, guess what? It can sink. So there's always that possibility. Again, more dramatic consequences from that in aviation than on the highways, but that still needs to be part of the equation, is what if the automation fails. Number two is actually much, much more likely, which is what if the automation encounters situations that weren't even considered by the designer of the automation. That's a much more significant challenge, and it's, by the way, automation on the streets and highways is going to be much, much more challenging than automation in the air, because streets and highways are much more variable and less predictable than the air. So that's why I'm just talking about learning 1.01, which is learning from aviation, but there's lots of other learning that has to be done of other issues that are going to be encountered in aviation in AV that weren't encountered in aviation, but one they need to think about is, what if the automation encounters unanticipated circumstances? And I can give you several aviation accidents of that ilk, plus accidents in every other mode. The reason I'm talking mostly about aviation is because of the commercial transportation that the NTSB looks at, that is by far the most automated. So that's the one where we can really learn lessons. So graceful exit means you need to have a plan B if plan A doesn't work. What is your plan B? So those are some challenges that, as we go towards autonomous vehicles, we need to think about. A, what if it fails? Not likely, but not impossible. B, what do we do in case it encounters unanticipated circumstances? Very likely. I mean, I can think of, I'm driving more and more these days with my head on, what would an autonomous car do in this situation? So I cross a very wide intersection where you have to do some lateral movement to stay in the lane, and I'm thinking, well, I bet you that would be a challenge for the lane keeping in this autonomous vehicle, because how does it know about the lateral movement that's necessary to stay in the lane on the other side of the intersection? Or the departure as the roadway leaves and the line leaves with that roadway, and if the line on the left side isn't so clear, then what is my automation going to do when it loses kind of lines on both sides? So those are the kinds of ideas that need to be addressed, and I know they are being addressed. I'm not suggesting anybody's sitting on their hands, because I see a lot of exciting movement, and that's why I'm so confident that we're going to be able to do this, because I see people looking at these problems, addressing these problems in very exciting ways. And so that's why my bottom line is most definitely we can do this. The third thing to learn from aviation is that humans are not good monitors of reliable systems. And that presents a challenge in the development, because in the development, if you want your car to be good on the streets, it's going to have to be tested on the streets. That's the bottom line. It's not, no amount of testing you do in the lab, no amount of testing you do on your test track is going to make it ready for the very variable and unpredictable streets. The only way you're going to do that is test it on the streets, and that means assuming you're not going to even go to the streets until your car is very reliable, then you've got the challenge of your monitoring a very reliable system. And that's what happened with Uber. Full disclosure, Uber engaged me to help them figure out, they stopped going on testing on the streets immediately. They engaged me to help them figure out how to get back on the streets, and I'm happy to do that. But that's a lesson learned, is that was such an inevitable accident that sooner or later there was going to be some event where something happened and the monitor happened not to be looking up. It didn't have to be for some bad reason like on texting or anything, but just looking in rearview mirror. Could be looking at any number of places. That was just a matter of time, and I wouldn't be surprised if I see it again with these very reliable cars being street tested with monitors, and monitored just at that very second. Happens to be something in front of the vehicle when the monitor's not looking up. So you have to, it requires training of the monitor, better training of the monitor to make them aware that humans are not good monitors of reliable systems, and it requires systems that are good at feedback to the operator that I'm not sure what I'm seeing, you better take over here real quick. And I know that's a problem too, because we've seen all those studies about how long it takes to take over. But the point is, this is a lesson can be learned from aviation, is how to respond to that reality, that human reality, that drivers are not good monitors of reliable systems. That's why there's all this talk about let's eliminate level 3, because that's what level 3 is about. You really don't necessarily have to be engaged, but sort of you do. That's not going to work. So there are lots of lessons that could be learned, both at a high level in terms of collaboration versus competition, and at a more implementation level of automation. And I'm excited to see a lot of people who are here today, and I know that you are going to learn those lessons from aviation, and I'm really excited to have this opportunity to play a role in helping you do that. And thank you again, Marta, for inviting me to speak. So I see automation is going to happen, but there are many challenges. And the real challenge is how to minimize the missteps so we don't scare an already skeptical public. But I think that step number one, learning 1.01, is learning from the aviation experience, who's been there, done that, and made amazing progress with it, as you can see from their very exemplary safety record. So thank you again for the opportunity to speak. I look forward to working with you in the rest of the day. Thank you.